15 Facts about Mars, the remarkable red planet. 1. Crisscrossing canals. In 1877, an astronomer by the name of Giovanni Schiaparelli used the term canali to describe streaks on the surface of Mars. If you translate canali, it was meant to mean channels. But people wrongly interpreted the meaning as canals. Since then, the general public believed intelligent life on Mars constructed a system of crisscrossing canals on the red planet. But it was the Mariner 4 spacecraft that quickly put that theory to rest. As it flew by Mars in 1964, it found it had no signs of life. It was actually bone dry, without any water either. Two, evidence of liquid water. Despite Mariner 4 finding no signs of life, the Mars Curiosity rover landed on Mars in 2011 in search of a similar goal. Its primary objective was to find if Mars could have ever supported life. The Mars Curiosity mission showed much more promise in finding signs of liquid water on Mars. For example, it found evidence of water in sedimentary rocks that formed in ocean-like settings. In addition, it discovered various forms of hematite that only form in water. Lastly, it found signs of chemical weathering also due to water. All signs point to Mars having water. 3. Curiosity rover's uncanny longevity. There have been 39 missions to Mars, but only 16 of them made it. Out of the 16, the most successful program of NASA was putting 2 rovers on Mars. The main objective of the Opportunity rover was to characterize rocks, soils, and minerals for clues about water. The purpose of the Curiosity rover was to investigate the building blocks for life. It was designed to last for 90 Mars days, sols. But more than 5,000 sols later, the Mars rover is still discovering. As it got stuck in the Martian craters, it was able to maneuver itself out to safety. 4. Mars quakes. Was there ever life on Mars? Possibly. Could we live there? First, we would need to discover a source of water. And this brings us to NASA's InSight mission. This mission is determined to find out what's beneath the dusty red crust. By drilling a hole deep into the Martian surface, it will measure tectonic activity, Mars quakes, and temperature flowing within the planet. In addition, it could also show signs of underground water reserves, which would indicate the possibility that life could exist on Mars. 5. An orange-red appearance. If you've ever seen Mars from a telescope, the first thing you'll notice is its orange-red appearance. Actually, Mars is dusty and filled with desert sand and rocks. But why is Mars red? Mars is 4.5 billion years in the making. When the planet was filled with water, iron oxide rocks and sand gave it a rusty red color. As dust storms sprinkled the rusty material around the planet, it blanketed the surface in red. Furthermore, Mars has dust storms that cover the entire planet and last for weeks. These dust storms are so influential that they can change atmospheric temperature. 6. The towering Mount Olympus. Mount Olympus is the largest volcano in the solar system. Its height reaches nearly 25 kilometers tall, more than 3 times as tall as Mount Everest. Whereas Valles Marineris is a system of canyons, some more than 7 kilometers deep. This span of canyons extends from about New York to Las Vegas, 2,500 miles. Another prominent feature is the Tharsis Bulge. This uplifted volcanic plateau is positioned near the Martian equator. 7. No magnetic field. Mars has no global magnetic field. But it may have had one at some time. It's believed that Mars lost its magnetosphere about 4.2 billion years ago. So now without a magnetic field, that means that if you were to bring your compass to Mars, it would be completely ineffective. Because Mars doesn't have a magnetic field, solar winds have stripped away much of Mars' atmosphere into the cold, arid planet Mars is today. Also, without a magnetic field to shield it from the sun's deadly rays, it leaves the possibility of life on Mars virtually non-existent. But understanding Mars' magnetic field can contribute to understanding if there was indeed a warm and wet climate that could support life on the red planet. 8. Phobos and Deimos are its moons. If I could control the Mars rover for a day, I would start examining rocks on the surface. Next, I'd look straight up in the sky. But it wouldn't be the familiar sight that we're used to on Earth. I'd notice 2 moons orbiting the Martian planet. Unlike Earth, which has a single moon, Mars has 2 moons, Phobos and Deimos. In terms of size, they are among the smallest moons in our solar system. Both moons are named after Greek mythological twin characters. While Phobos means panic/fear, Deimos means terror/dread. 9. Mars has Earth-like environments. Mars has Earth-like environments like dust storms, deserts, sand dunes, and ice caps. But much of the planet is blanketed by red dust, so they share a little resemblance. Ice caps on Mars are not made of water. Although they are similar in appearance, white at least, ice caps on Mars are composed of carbon dioxide. Mars is cold, but not terribly cold. Like Antarctica, it ranges from -87 degrees to -5 degrees Celsius. This is because it's farther from the Sun than Earth. It's about 228 million kilometers away from the Sun. That puts Mars at about 1.524 astronomical units. 10. It's 1/3 of Earth's gravity. Mars has a thin atmosphere because its gravity is about 1/3 of Earth. Similar to Venus, Mars' atmosphere is 95% carbon dioxide. If there were plants on Mars, they would blossom with that much CO2. All they are missing is a source of water and sunlight. The atmospheric composition of Mars is carbon dioxide, 95%, nitrogen, 3%, and argon, 1.6%. 11. Mars sits next to an asteroid belt. In between Mars and Jupiter are mostly asteroids. The asteroid belt formed because of the strong opposing gravitational pull of the Sun and Jupiter. In opposite direction, the Sun and Jupiter pull. Like a tug-of-war, other planets cause them to stay in between. These planetesimals are the remains of a terrestrial planet that disintegrated in outer space. These pieces of odd-shaped rock did not mold into planets of their own and remain in the asteroid belt. 12. Rifts and crustal deformation. Mars has bits of evidence of volcanic activity in the past. For example, on Earth, when 2 plates rub together, it deforms the crust. This process sculpts prominent features like ridges and volcanoes. On Mars, similar features exist, such as the Tharsis Bulge, Mount Olympus, and shield volcanoes. However, similar to plume volcanoes, it's believed that Martian volcanoes melted within the mantle and then raised buoyantly through the crust. Currently, there is no tectonic activity because of how much it cooled down. It's possible Mars is still volcanically active. But we just haven't observed any eruptions. 13. Seasons are twice as long. Similar to Earth, Mars has a summer, spring, autumn, and winter. This is because Mars rotates on a tilted axis. While Earth's inclination to the equator is 23.5 degrees, Mars is about 25.1 degrees. But seasons on Mars generally last twice as long. This is mainly because of its orbital period, Sol, and its eccentric orbit. For example, 1 year on Mars is almost twice as long as on Earth at 687 days, 1.88 Earth years. Its day length is close to the same at 1d0 hours 45 minutes. Without water, seasons don't resemble Earth. Water can't freeze to make snow. The only snow clouds on Mars consist of carbon dioxide. So, White Christmas isn't the romantic scene you might picture. 14. Mars is in the Goldilock zone. Not only is Mars in the Goldilock zone, but it's also one of the 4 terrestrial planets in our solar system. Just like Mercury, Venus, and Earth, they're all small, dense, and made of similar stuff. Terrestrial planets tend to be rich in metals and silicate rocks. Mars' inner core is made up of metallic iron and nickel. Unlike gas planets, it's surrounded by a less dense, silicate mantle and crust. Finally, its red surface rocks and dust are caused by the oxidation of iron. 15. Evidence of volcanism. There's significant evidence of volcanism on Mars. And if you have that much volcanism, this means Mars probably had a thick atmosphere and probably an ocean hundreds of meters thick. What makes people think this is because everywhere on the surface of Mars you see evidence of water, stream beds, riverbeds, and erosion. For example, the largest volcano in the solar system is the Olympus Mons on Mars. This shield volcano towers over 27 kilometers in height. Based on space imagery like Mars Orbiter Laser Altimeter, MOLA, Mars has shown evidence of leaking on cliff walls and water leaking out into space.